Okay, here's an example involving the quotient rule for derivatives. We're given this function h, and we're told that h of 2 is equal to 4. So if you want to get a mental picture, we know that the point 2, 4 is on this function. H is some function of x. And we're told that h primed of 2 is negative 3. So at this point x equals 2, the slope of function h is negative 3. So about like that. Now I don't know if this function is doing this or if it's doing this, but I know that when it goes through this point right here, at that instant, right there at that point, it has a slope of negative 3. That's function h. I only know what it looks like right at that one point. Then I'm told find the derivative of h of x over x at x equals 2. Now h of x over x, that's a quotient, one function over another. So I'll use the quotient rule. Both of these are functions. H of x is a function and x is a function. X is a very simple function, but both of them are functions. So I use the quotient rule. And I think of the quotient rule as low d high minus high d low over low low. So low is x. Well, let me write this out. The derivative with respect to x of h of x over x is low d high, and low down here is x. And then the derivative of what's up top, that's h primed of x, minus high, which is h of x, times the derivative of the denominator, and that's the derivative of x, which is 1. X is a function. The derivative of that function is 1. And then I need to divide by the denominator squared, which would be x squared. Now I can put in numbers here. I'm told to find this derivative at x equals 2. So I can put in 2 for x here, and h prime of x will be h prime of 2, and I'm given that, and h of x here will be h of 2, and I'm given that. So I can just put in these numbers and do the calculation. X is 2, h primed of x is negative 3, so 2 times negative 3 minus h of x, and x is 2, h of 2 is 4, minus 4 times 1 over x squared, and x is 2. So that's over 4. So this works out to negative 6 minus 4 over 4, which is negative 10 over 4, or negative 5 halves. Okay, now I want to address one question here. One of my students asked me, when we do the low d high minus high d low right here, low d high minus high d low, when we do the derivative of the denominator right here, if x is 2, right there, if x is 2, why don't we say the derivative right there is 0? Okay, when we're doing this derivative, h of x over x, h of x is a function and x is a function. And the quotient rule, as it's derived, is the quotient of one function divided by another. And we were told in this case to find the derivative with respect to x of h of x over x. That's just like saying the derivative of f of x over g of x, where both of these are functions of x. X happens to be a simple function, but it's a function. X right here is not a value. In other words, we're not finding this, the derivative with respect to x of h of x over 2. We could find this, but that's not how the problem was stated. We're told to find the derivative of h of x over x. So when we're calculating this, what we're finding really is a function. The quotient of two functions is a function. And this function has a derivative, which is a function, and the function down here also has a derivative, which is a function. And their quotient has a derivative, which is a function. And we calculate that with the quotient rule. And the way the quotient rule is derived is when we do that calculation, we're doing the bottom function times the derivative of the upper function minus the upper function times the derivative of the lower function over the lower function squared. And the result is another function, which is the derivative of the quotient. And that's exactly what we did right here. we found the derivative of this function using the quotient rule, and this is a function. And then if we want to find the value of this derivative at 2, then we plug in x equals 2 into this function here. But we wouldn't plug that 2 in before we took the derivative.